Now, let's look at if the objects are in motion. Okay. Let's identify the frictional force. In this case, it will not be static frictional force and kinetic friction force. Let's compare to see the difference here. So, for the following configurations, assuming all the surfaces are frictional, identify all the frictional forces acted on two blocks. If A, blocks are moving together with constant velocity. B, blocks are accelerating together. So this is static. Okay, this is static. We keep it here, and then let's look at if I still have the two situation. Okay. I still have the two kind of cooling situation, but now they are moving with constant v, moving with constant v. So let's try to identify the frictional force. Okay. So the first one, you can compare it with, should it be the same as this or similar to that but totally different? So in fact, it's quite similar to that. The only difference is, of course, in this case, it's moving. So instead of have some static frictional force, you will have kinetic frictional force. But still, we have only one frictional force at the ground, from the ground, and you don't have frictional force between the two again. Because both of them are moving, okay, with the same constant velocity. So it's kind of similar to the situation. We know that state and rest, there is no essential difference between the state and rest or constant velocity motion. Okay, but the only difference is here. It's not moving. This is static frictional force. This is the kinetic frictional force. Okay. Let's check this one. Is it similar or different?
So it's not moving because of force.
Okay, both of them moving with constant velocity. So there is no relative motion between them. So this is still static frictional force. So this is also a static frictional force. But how about this one? This is the kinetic frictional force, right? Both of them moving together on the ground. Any question here? Compare with the situation.
Wouldn't you actually have to use numbers and analyze the second one to figure out if block 2 will move with block 1?
Hmm? What? Number? Yes, 1, 2, 1, 2.
On the second one,
Mm-hmm.
if the static friction between block 2 and the ground is bigger than the static friction between block 1 and 2, block 1 will move by itself, right?
You say, do you want to compare this and this?
No.
Or here?
Block 2 and the ground.
Here?
Mm-hmm.
These two?
Yeah. Your block
Okay,
one.
yeah, okay, here first I will use the number because in this case, the nature of the two frictional force should be different. This is static friction, this is kinetic friction, but the magnitude should be still the same.
Wouldn't it depend on the static friction force?
Okay.
Block 1 can move by itself if the static friction between block 2 and the ground is greater than the static friction between block 1 and 2.
Okay, so here you can think about this. The static friction, it has some range, can adjust. It can adjust its own value to match the kinetic friction. Only that match is possible, then both of them can moving with the same velocity. Okay. If it's not possible, then I don't even have this situation. Okay. To have this situation, the static frictional force has to have the same value because all these forces should have the same value. They cancel each other, so it can move with constant velocity. Okay. So in this case, similar to here, this equals to this. So it will not move object 1. Hold on. Okay, yes. And this Fk has to be the same as this Fs. So object 2 will move with constant velocity. It's in motion, but it's not accelerated. So the two forces should be equal to each other to give you 0 acceleration. Okay. And since this equals to this, they are action and reaction. So all the forces are equal with each other. Any question here? And of course, this is possible because the maximum Fs can usually larger than Fk. So what happens is that if it have a smaller value than Fs max, it can match Fk. Okay. Any question? Now let's look at the accelerated motion. Okay, let's examine if this you have some acceleration. So what happens in this case? Okay, the hint is now it can be quite different. So can you help me to identify the frictional force?
The frictional force would be applied on the ground in the direction opposite of force applied.
First, you should have some frictional force here, right?
Right.
Okay. Of course, Fk is in motion. And of course, this Fk, in this case, Fk should be smaller than F, otherwise it's not accelerated. Okay. Now, the question is, in this case, do we have some frictional force between 1 and 2? We do. Okay, so you should have some frictional force F, S, and F, S. Oh, sorry. Okay, like this. That's the correct analysis. Any question here? So you can see why I can identify this frictional force. Think about the whole system is in acceleration. So if we only look at object 1, that means it must have some forward force to maintain the acceleration. Okay. If it doesn't have forward force, then it wouldn't accelerate together with the second object. And the only possible force to maintain this acceleration is some frictional force here. So, of course, then reaction will be in this direction. So block 2 actually has 2 frictional force opposite to F. And this plus S should be smaller than F. So there is really one more strong condition to that. Okay. Any question here? And for the whole system, of course, these two are internal force. Okay? Now, if I'm putting this with some external force. Now let's check what difference makes. So of course I'm putting it anyway. There must be some static frictional force here. Okay, if these two are not moving together, the friction force can only be static. Okay, and so if there has some static frictional force, there must be some static frictional force, and then here must be some kinetic frictional force because the whole system moves to that side. There is some relative motion, so kinetic frictional force. So the graph doesn't, it looks quite similar to that one, okay? But the difference from this one and this one is, in this case, all the forces equal to each other. So there is no acceleration. But in this case, these forces may not be the same as each other. In fact, this one should be larger than this one. And this one should be larger than this one. Okay, so in this case, you can see Fs should be smaller than F, should be greater than F, this Fk, to make the accelerated motion. Okay, and this one, you got Fs equals to Fk equals to external F. And similar here, you have Fs and Fk, but Fs must be equal to Fk in this case. Okay. Equals to external F. Oh, you don't have Fk. All of them Fs, so F equals to Fs. This equals to the 3 static frictional force. And this one, you should have F is greater than Fk. Okay. Any question here? Also F greater than Fs.
So could Fk and Fs equal to each other?
In this case, let's check. So far you cannot say that. It depends on the mass of object 1 and 2. Okay. Any question here for this analysis?
Yes. On static number 2, when you have the force on block 1, how do you have motion in that if force applied is equal to friction static?
You are talking about which? This one?
No, constant V. Sorry.
This one?
Yes.
So what's your question?
How do you have force? Because if friction kinetic and friction static is equal to force applied, then all the forces cancel each other out, so you shouldn't have any movement.
Remember, if all the forces cancel, you have acceleration equals to 0. You can still have motion, which is constant velocity motion, if it's originally in motion. I can somehow make it move, do some initial setup to make it move, and then maintain this kind of situation. Okay. Note that all the forces cancel only says that acceleration equals to 0. But acceleration equals to 0 doesn't mean it has to be a stationary state. It can still be constant velocity. So that's why when both of these motion, state of motion, but constant velocity and acceleration are totally different. Okay.
Can you explain to me how motion starts in this situation?
The start you can do like this. Initially, you apply a larger force to make both of them move, and then you can reduce the force, make all of them the same, and it will reach some zero acceleration state. And it will keep the velocity it had at that point. Okay. And in fact, that's also, you know that in your experiment. To make it move, initially you have to have some larger force. But then you can reduce your force a little bit. Okay? Oh, yes. There's another important information that mu k is always smaller than mu s. So the kinetic friction is always smaller than maximum static frictional force. Okay. That's also why this can be realized. If not the case, probably you cannot get this kind of situation. So please note that kinetic friction is usually much smaller than the maximum possible static friction. Okay. But of course, doesn't mean that kinetic friction is always smaller than the actual static friction, of course. Static friction, of course, depends on external cooling, can be made very small.